Now let's work on simplifying trig expressions by using different algebraic techniques. So let's say that I wanted to simplify or write cotangent of theta over cosecant of theta in a different way. So I'm going to write this in a way that would be different so that maybe it looks like the other side of my equation of my identity. A common method whenever you have cotangent, tangent, secant, and cosecant, if you're multiplying or you're dividing, one common thing that we do to rewrite is to rewrite it in terms of sine and cosine. So cotangent is cosine of theta over sine of theta, and cosecant is 1 over sine of theta. Alright, and so if I rewrote this like this, then I have a fraction. I have fractions within fractions, but I can deal with that. Take the fraction in the denominator, flip and multiply, and you get cosine of theta. So, I mean, looking at cotangent of theta over cosecant of theta, more than likely you just didn't see that's equal to cosine of theta. But it is. And the only way we could figure that out is changing everything sine and cosine, and then doing some algebra, flipping, multiplying, canceling out to get cosine. So if you ever see a quotient or a product that's not sine and cosine, then maybe change it over to sine and cosine and see if it'll simplify. Alright. Another common algebra technique is if we have something like this. Say I had sine of theta over 1 plus cosine of theta. Anytime you have some number plus a trig function in the numerator or denominator by itself, then you want to multiply by the conjugate, or I'm not saying you want to, but one common technique is to multiply by the conjugate of the two terms, like the number plus or minus a trig function. You multiply that times the numerator and denominator. Okay, so if I did that here, let's see what I would get. I'm not going to multiply out the numerator first, and you'll see why in just a second. I'm just going to write it as the product of sine of theta times 1 minus cosine of theta. And the denominator, remember when you multiply conjugates, you don't have to FOIL it all the way out because the middle terms are going to cancel out. You multiply the first terms and the last terms. So that's going to be 1, and then positive cosine times negative cosine, that's going to be minus cosine squared theta. And so anytime I see 1 minus cosine squared or 1 minus sine squared, you need to think about Pythagorean identity. Because we have a Pythagorean identity that is sine squared theta plus cosine squared theta equals 1. And if I solve for sine squared or I solve for cosine squared here, that means just getting it by itself. Let's say that I want to see what is 1 minus cosine squared equal to. So to do that, I would have to move this term over. So I have sine squared theta equals 1 minus cosine squared theta. And so 1 minus cosine squared theta is equal to sine squared theta, so you could take and plug it in for those two terms there. And if you do that, then I'll have sine of theta times 1 minus cosine of theta over sine squared theta, and then my sine would cancel out, one of my sines would cancel out and leave me with 1 minus cosine theta over sine theta. And so it's not like it's simplified just to one trig function, but it was a way to rewrite this original term. Alright, the original term or expression was sine of theta over 1 plus cosine of theta. By multiplying by the conjugate of 1 plus cosine theta, I changed it into 1 minus cosine theta over sine theta. So that means those two expressions are equal. So it's just a way of rewriting something. Just a common algebraic technique that we have to use to help us solve trig identities. Alright, another technique is getting a common denominator. So getting a common denominator can be as easy as, if I wanted to add 1/2 and 1/3, then my common denominator would be 2 times 3 or 6. And so then I'd say 6 divided by 2 is 3. 3 times 1 is 3. Plus 6 divided by 3 is 2. 2 times 1 is 2. So I'd get 5/6. Well, let's say that I had cotangent theta plus tangent theta. If this was my expression and I was trying to rewrite it in some way, then what I would want to do is first I would make cotangent theta cosine theta over sine theta, and I would make tangent theta sine theta over cosine theta. Alright, we can write this in a different way by getting a common denominator. The common denominator is going to be the product of these two denominators. So my common denominator is sine theta times cosine theta. So if I take that common denominator and I divide it by sine of theta, sine theta cosine theta divided by sine theta would just leave me with cosine theta. So you say cosine theta times the numerator, which happens to be cosine theta. So cosine theta times cosine theta is cosine squared theta. Plus, look at the common denominator. Now look at this denominator. You say sine theta cosine theta divided by cosine theta. So that would get rid of the cosine theta and just leave you with sine theta. So you have to say sine theta times the numerator, which again on this problem just happens to be sine theta. So sine theta times sine theta is sine squared theta. Now I see sine theta or cosine squared theta plus sine squared theta. Remember, this identity up here is sine squared theta plus cosine squared theta equals 1. So cosine squared theta plus sine squared theta is also equal to 1. So this is 1 over sine theta cosine theta, which I could rewrite by, if you take the sine of theta and move it to the numerator, it becomes its reciprocal, cosecant theta. If you take cosine and move it to the numerator, it becomes its reciprocal, secant theta. So who would have known that cotangent theta plus tangent theta is equal to cosecant theta times secant theta? It's not something that you can just see, but by changing this to sine and cosine, getting a common denominator, applying a Pythagorean identity, and then using the reciprocal identities, I could rewrite that in another way. Maybe that would help me solve part of an identity. Alright, one of the last ways we're going to go over is sometimes we may need to factor to rewrite things. So for example, say part of our identity we have the expression sine squared theta minus 1 over tangent theta sine theta minus tangent theta. Alright, so you may not see right away that things would factor, but it looks like I can factor the numerator and I can factor the denominator. The numerator is the difference of two squares. So I would factor that. Let's say sine of theta, 1, 1, plus, minus, over. In the denominator, they both have a tangent. Both terms have a tangent theta in common. So I'd factor a tangent theta out. And that would leave me with sine theta minus 1. Alright, and now that I have the numerator factored and the denominator factored, notice that these factors here cancel out, and that just leaves me with sine of theta plus 1 over tangent theta. So factoring and canceling out is always an option too, so don't forget that.